linear system consists of two or more linear equations. The solution of the system is the x and y that satisfy each equation. So if you think about two lines, it's where the two lines intersect. So let's look at this example. This is two lines, and they're in standard form, so we can graph them. It's the first one right here, when y is equal to 0. So we're looking at the first one here. When y is equal to 0, we're on the x-axis. So when y is equal to 0, we have negative 2x is equal to 18. So at y equals 0, oh, this is the first equation. So let me write that. The first, at y equals 0, negative 2x equals 18, or x equals negative 9. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have our x-intercept. And at x equals 0, we have 6y is equal to 18, or y is equal to 3. So that is our y-intercept, 0, 3. Now we just throw a straight line up there. Whoops. Put some arrows at the end just to make it look pretty. And now let's graph this guy. So equation 2. Well, we could do the same analysis, so you could just see that the the intercepts are negative 1 and negative 1. So let's get our drawing tool out. And if we graph this well, and I did not, but that's not the point here. If I graph this well, right here, this intersection is 1, 2, 3, x equals negative 3, and y equals 1, 2, 2. So this negative 3, 2 is the point that these two lines share. And let's double check. Let's put it back into equation 1. Y is 2 and x is negative 3. So 6 times our y, which is 2, minus 2 times a negative 3. Well, that's equal to 12 plus 6, and that's equal to 18. So that checks out that it's on the first line, and then we can check the second line too. So that's by graphing. And here is steps for solving linear systems by graphing, and this is when using a calculator. Because a calculator, or at least, oh my gosh, that's a terrible calculator. A calculator doesn't understand the relation x plus y equals negative 1. Calculator only understands when we take this information and transform it into a form of y equals, and then there would be no y's over here. So this is only x's, so it only works when we set y is equal to a function of x. So step 1, write both equations in x. In other words, solve each equation for y. You want to get to y equals. Find the coordinates of the intersection after you graph. Sorry, I put and graph. Find the coordinates of the intersection. Check your solution by plugging the coordinates back into the original equations. We go back to the original equations because we are admitting that there's a chance that when we did this manipulation, we could have made a mistake. Then write your solution as an ordered pair, which looks like this, an x, comma, y. All right, so let's solve this one for y. We get y is equal to negative 4/3 x plus, actually I'll do it that the long way. We have 4x plus 3y equals negative 3. So this is equation 1. Subtract 4x from both sides, and we get 3y is equal to negative 4x minus 3. Divide both sides by 3 and distribute. We get y is equal to negative 4/3 x minus 1. And what about equation 2? Equation 2, well, I'm going to just start by subtracting x from both sides. Save some room over here. We get 3y is equal to negative x plus 6 divided by 3. And we have y is equal to negative 1/3 x plus 2. All right, so we've got a calculator here. Yes. All right. I still have my peanut in there. Let's go down, make sure we're on function. If you have a calculator, getting good at your calculator is very valuable for any engineering. All right, so we have two equations. Here's one, and here's the other equation. So we're going to put both of those in. Okay, y equals negative 4/3 x minus 1. Delete this garbage over here. And then down here we have negative 1/3 x, whoops, x plus 2. If we had to adjust a window, we'd have to adjust a window. We'll look into some of those later. So here's this button right here, calc trace. You want to write that down, maybe jot it down. Second, we're going to call up calc. We're going to go down to intersect. Now this prompt says first curve. The mouse is on the first curve. Enter. See how the mouse jumped up to the second curve? We hit enter to say yes. Do we want to guess? Heck yeah. And it goes right over here. The intersection is negative 3, 3. So let me write that down as our ordered pair. And now let's throw the picture up there. Okay, so it looks like one graph, one looks like that, and the other one looks like that. That's not very good. That's my point there. And then it's like that. Okay. You'll draw it better. Okay, how about this one? Solve the top one for y. So here's equation 1. 1 is not a lot of room here to work. So I'll work down here. For equation number 1, we would get y is equal to negative 3/7 x plus 2. And for our second one, we would get y is equal to 5/7 x. And then 42 divided by negative 7 is negative 6. So I'm not going to show the steps for that. but that shouldn't be beyond you to put those in. So now we go to our calculator and just put them in. Y equals top one, negative 3/7 x plus a deuce. We'll go to the other one. This is 5/7 x. Take away 6. Graph. Oh, I got lucky in my window again. I'm about to get unlucky in my window. So remember, here's our button. Second calc. Intersect. First curve, yes. Second curve, yes. Guess, yes. Pops right over to there. 7, -1. 7, -1 is right there. We have this graph for line 1, and the other graph for line 2 look like that. Okay, let's keep going. Some of these we can do without even, well, maybe without putting in. So we have y is equal to 2. That's one line. And how about this one? This is y is equal to -4x minus 2. So our intercept is -2. We go up 4, 1, 2, 3, 4, and back 1. Well, that was easy. That was easier than putting it to a calculator. There's our intersection, -1, 2. And putting it back into the original equations is the next step to check. Okay. How about this one? Standard form. Both of them are in standard form. So for this one, for the top one, we get intersects of 1 and 1. Oops. So there's our first equation. And our second equation, we get intercepts, let's see, at y equals 0, and this is equation 2. At y equals 0, we get 2x is equal to 12. So x is equal to 6. That's all the way out here. That's our x-intercept. And then for x equals 0, we put x is 0 right there. We get -3y is equal to 12, or y is equal to -4, which is right there. So we're going through these 2 points, and now we get our drawing tool. Stick up some arrows, and look at that. Right there is our intersection, 3, -2. So for this one, 3, -2. And this one, well, this one we actually can't graph because it's impossible to get this into y equals. So far as I know, we can't put that in a calculator. So here we go. X is -2 is that line. And how about this line? Well, let's solve it for y. And we get y is equal to -3/2 x plus 1, which is right there. -3/2 goes down 3 and over 2. So back 2 and up 3. Oh, right there. Okay, those are straight solves that are easy for graphing. I think the next ones are some of them coming up. We're going to use our calculator. Okay, is 4, 1 a solution of these? So we just put 4 in for x and 1 in for y. I put little subscripts of 0 in there. We put those in here to see if it's true. So is 4, 1. So remember, the x is first. So is it true that 1, we're put it, this is equation 1. Is it true that 1 is equal to 3 times 4, take away 11? Well, that's 3 times 4 is 12, take away 11 is 1, so yes, so it does satisfy this. And let's do equation 2 now. Put x and y, just put them right in. 4 minus 1, is that equal to negative 1? No. So this would be no, so the answer would be no. How about this one? X is 4, well, that checks out. X is 4, yep. Now how about this one? Is 2 times 1 equal to 4 take away 2? Right, so I just put y and x, 1 and 4 in there. Okay. That's true. 2 times 1 is equal to 4 take away 2. So boom. So the answer is yes. Reset your window. Okay. So I'm going to have to let you do, well, I'll do this one. I'll do this one. So, and this will talk about windows. So just because the numbers are bigger doesn't change the process. So for number 1, 44x plus 50y is equal to negative 36. So solving for y, we subtract 44x from both sides. This is equal to 50y. Then divide both sides by 50 and be sure to distribute. These 50s cancel, and this is our first line. And the second line is just y equals x plus 176. So let's throw those up in the calculator. So let's go to y equals negative 44 divided by 50. That's all being times by x. Take away 36. I'm putting it just like it's written there, but just be careful with order of operations and getting the right things in parentheses. So there's my top equation. My bottom equation is just x plus 176. X plus 176. This is a good exercise right here, because watch what happens. My graph, we don't see the other graph. We don't see the other equation. We don't see the other relation. This is the, well, actually, you tell me if this is the top curve or the bottom curve. It's the bottom curve. This is the only, I mean, it's the, sorry. Is this the first equation or the second equation? It's the first equation because this is a negative slope. So we're looking for the second equation, and we have to back up. So we're going to do zoom, zoom out, enter, and see if we can find it. We just keep it in enter, zooming out. Still don't see it. There it is. I zoomed out far enough. Second, calc, intersect, boom, boom, guess, yes, and negative 94.82. Negative 94, comma 82. I'm going to leave these guys for practice on the calculator for classwork. These would make good problems. Don't forget, if lines are parallel, then there is no solution. Because two lines that are parallel never intersect. So we'll have no intersection. So here's line 1 and line 2. And no solution. If lines are the same, so two lines can be the same but just have different forms, then there are an infinite number of solutions. It's all of the points on the line. Okay.